know that you need to know how to do these things without a calculator. Because let's say you get a question like that on a test. Notice I'm never using a calculator to find the asymptotes, right? Okay. So what I need to be able to graph this is I need my vertical asymptote. Where is that? If I set this to 0, do you agree that I would have to go plus 2 divided by 3? So at 2/3, okay? My horizontal asymptote. Do you see how I have x on the bottom, no x's on the top? That means the power of the x's on the bottom is 1, and the power of the x's on the top is 0. That's a bigger on the bottom. So it's at 0, but then minus 1, so negative 1. And that's the first thing you're going to now draw in your graph. You're going to go to your graph, which is a scale of 2. So at 2/3, so that's one somewhere here. So it's pretty close. You have your vertical, and maybe mark it for yourself 2/3. And at negative 1, you have your horizontal. Which means you are going to cross the x and y axis, unlike the original graph that doesn't, because the original graph has asymptotes here and here. So you never have x and y intercepts, but here you are. Now how do we find the y-intercept of any equation?
Take out the x, set the x to
Make the x be 0, substitute x with 0. So for the y-intercept, you go 4 over 3 times 0 minus 2
-3.
minus 1. So you get 4 over negative 2, which is negative 2 minus 1, which is negative 3. So now on the y-axis, you go to negative 3, which is here, and you put a point. Do you agree that the x-intercept is when y equals 0? When the function itself equals 0? When you have a fraction, if the numerator equals 0, the outcome is 0, correct? So to find the x-intercept, you either put here a 0 and solve, which I would do in this case, but if you don't have this, just set that to 0. Okay? So if it wasn't this, there wouldn't be an x-intercept, because 4 doesn't equal 0. Because it's that, so for x-intercept, so I'll give you a way that always works. You set y to equal 0. Right? There's your equation. You're going to go plus 1. Right? Put this over 1. So you go this times this equals this times this. So 3x minus 2 equals 4. So 3x equals 6, so x equals 2. You go to 2 and put a point. Here is bothering you.
Yeah. Shouldn't that be on the x-axis?
Yes, sorry. I just looked at it, so that's not going to give me the right shape.
Yeah, it's
So there
crossing,
you go.
crossing.
No, that's my mistake. Exactly right. So there, I'm here. Now it looks good. Yeah. Now I know when you'll go to the calculator to find a couple of more points, I know that my graph's going to end up looking like this and like that. But find, we're out of time, so just find another point that won't always be so smushed and easy doing it. Okay?
Good question. How would you graph that in the calculator? Because I just graphed it and it
Go
didn't.
4, you would do this, parentheses, 4 over parentheses, 3x minus 2 plus parentheses minus 1.
Okay.
You have to change the order of operations for the calculator to do things in the right order.